Well, why don't we go ahead and get started with the intro. People can kind of come in as we do this. This is Denise. I am co-chair for the Education Committee, and we are talking about why carbon, industry trends, electrification, enhanced resiliency, and OpEx strategies and caddies of those. Glenda is going to go ahead and introduce our speaker, Jeff Wegner. Go ahead, Glenda.
Hi, everyone. Thank you for attending. This is Glenda Didion, First VP for IFMA San Diego. And I just really wanted to thank Jeff Wegner, first of all, and Jean Kogan for doing this presentation. We have been working on it off and on for a few months now. COVID obviously has made things more difficult, even with communication, surprisingly enough. But I met Jeff virtually via email through a very good colleague of his who did a construction project for Inovio about 3 years ago when we were building out our building Mesa Ridge. But without further ado, I just want to let you know a little bit about Jeff. He's a mechanical engineer with experience in mechanical. Sorry, can you hear me?
Yes, if everybody can mute their microphones, that would be great. Thank you.
Yeah, so again, Jeff is a mechanical engineer with experience in mechanical design and project management of life science facilities, mission critical combined heat and power plants, energy studies, advanced technology, and industrial facilities. His commitment to decarbonization designs is evident in his collaboration among multiple disciplines and his practical yet innovative approaches to successfully meet clients' needs. He is PECM Lead AP certified and alternative energy solutions subject expert at CRB. And his colleague Jean Kogan is also lead green associate energy and sustainability subject matter expert with CRB. He has experience in the energy sector with extensive engineering, strategic planning, and project management in high technology, corporate, utility, and government industries. Jean has provided engineering and financial feasibility studies on microgrids and distributed energy resources, or DER, to over 250 commercial and industrial sites globally. That's a handful, and I don't understand most of it, so we're hoping that they will enlighten us with all this information that they have about electrification. So, Jeff, do you want to take over?
Yeah, I appreciate that introduction. Let me see, I assume that you can hear me okay?
Yes.
And then let me go ahead and present my screen. Let me figure out my controls here. Bear with me for one moment. Let's see. Here we go, share screen. Host disabled participant screen sharing. I don't know if I need to be promoted. Denise or Karen, do you know if there's a way for me to get?
Yeah, I changed you to a host.
Fantastic. So let me share my screen too, and once you see screen two, let me know if you're seeing that.
You're good, Jeff.
Fantastic. Well, I really appreciate everybody's time today, and appreciate that introduction. And welcome to the 50th anniversary of Earth Day. So, really this presentation was not intended to be around Earth Day, but as we start to talk about the trends, I think it'll start to make a little bit more sense. So we actually gave this presentation as an internal series for a 5-day series. And so you can see those other agenda items on the screen, and we kind of merged this in, but I just wanted to put those up there on the screen in case there was topics that the audience wanted to hear from. We could certainly come back and expand on that. But really the topic that we thought this audience would be most interested in was the topic of electrification and how you can, what the benefits are and how you can accomplish that. So before we kind of dive into the details, I want to take a step back and even talk about why we're interested in carbon. And really, when you follow back the global temperature as it compares to CO2, that graph in the middle of the screen you're seeing that the temperature, the Earth's temperature follows CO2 with a pretty good correlation. And that timeline is 0 on the right being present day and 400 on the left. That's 400,000 years ago. So this is tracking a tremendous amount of time. This is through core ice samples. And you can see in the recent, just a couple hundred years, which would be that sliver, our CO2 has increased dramatically. So the question then becomes, is temperature going to continue to follow that CO2 trend? That's where the concern comes from. And then again, for clarification, when we say CO2 or greenhouse gas, global warming, those are all synonymous. We say CO2 because it's generally, it's what's rated. That's the biggest contributor towards greenhouse gas warming potential. So. But the thing, and so this slide does go into, what a temperature rise could have impact. And so off on the left-hand side, most people on the call have probably heard of the Paris Agreement, whether they fully understand it or not. Certainly the United States has been a center of a lot of that discussion. But there is, talks about, limiting the rise to either, that goal of 1.5 and certainly no higher than 2, because there are some irreversible things that can happen once you exceed that global temperature. That being said, there is good news in that our energy consumption in the US building sector has for the most part flatlined through a lot of energy conservation measures, which really in the last 10, 20 years, I think a lot of the focus has been on energy reduction. So we have made positive strides, because as we've grown, we've stabilized our energy consumption. And there's even more further good news in that, during that same time frame, the CO2 emissions have actually decreased. So while we're growing in GWP or GDP, we've maintained our energy, our CO2 impact has started to diminish, and that largely is to do with on-site or on-site, off-site renewable energy. So we're going to dive into a little bit of those details. One question I did not ask Karen, Denise, is if I don't know if there's going to be a chat window that people want to use, or if we want to open it up for questions, because generally this is where I would maybe pause and see if there's any questions from the group. But if you'd like me to keep going, I can certainly do that.
Yeah, that's up to you. I mean, if you want it to have a fluid conversation, that can definitely be part of the presentation. I think that's fine.
I will take a pause and see if there's any questions from the audience. Certainly don't mind a fluid conversation by any means.
Just to let you know, everybody is allowed to talk, so all they have to do is unmute themselves if they have a question.
So if there are questions, feel free, and you can always use the chat window, and I'll try to reference back to the chat window, and maybe I'll take a couple 1-minute pauses throughout the presentation. So if I don't catch you on this round, certainly I'll try to catch you on the next. But diving into industry trends, that's what I wanted to touch on next. And CRB, we do a lot in the life science industry, but really all of the advanced technology sectors. And what we're finding is that there is certainly a heightened sense of awareness around what we refer to as the corporate social responsibility, and those 3 pillars of sustainability being environmental, social governance, also known as people, planet, profit. And I mentioned earlier about the focus in the last 10, 20 years was all about energy, energy, energy. And if you look at these stats on the screen, none of them talk really about energy. They're all carbon, AKA greenhouse gas. So I will say that's been a tremendous transformation in the last handful of years, and we're just starting to see that evolve more and more rapidly. Most recently, last year's World Economic Forum, AstraZeneca had pledged $1 billion, which at the time was the largest that I had heard of. And since then, we've heard some others, like ironically, Delta Airlines, who consumes quite a bit of fossil fuel, pledging a zero carbon emission facility or future through offsetting. Certainly Bezos and Amazon have enacted other pledges. So we're constantly seeing more and more companies starting to kind of, one up one another, and this is becoming a very fast moving trend. Speaking here in California, October of 2017, Governor Brown signed into law Senate Bill 100, which made signed into law that the California grid would go 100% clean electricity by 2045. So that is now law. That has also spurred a number of local jurisdictions to ban or restrict natural gas. And so I realize the text on the screen is a little bit difficult to read. And so if you want to see this maybe in a little bit more of a graphical form, these are the percent of California population that is living in a location with a stretch code or a ban or restriction on natural gas. And so you can see there, once the onset of San Jose, that jumped quite a bit. San Francisco jumped quite a bit, and we're already pushing about 10% of the California population has that. Locally in San Diego, you'll see most of these cities are in the Bay Area, but here in San Diego, Carlsbad is one of the first, and that's not a ban, it's a restriction, or I guess you could say it's a ban for domestic hot water. And that was part of their climate action plan that was rolled out a couple of years ago. So again, just being aware of the different trends, and likely that's going to continue to grow. So CRB Stand. So we came up with our own stance for those companies that are looking for that forward-thinking approach towards sustainability. And we really kind of came up with this 4-part breakdown. And really it was step 1 is applying the best design and construction practices, and we don't feel like that'll ever go away. The most effective kilowatt saved is the kilowatt that's never used. So we're a strong believer in applying those best design and construction practices right out of the gate. As far as step 2 is, if you are looking for that carbon resilient future, removing those on-site fossil fuels as your primary fuel source allows you to most easily pave the way for that zero carbon future. But as you start to put more of that, more in that electrical basket, you want to start thinking about how do I protect that electrical basket? How do I create some more resiliency? And so we start thinking about on-site renewable power and time of use energy storage. And I'm sure a lot of people on the call today are getting hit with either demand charges, or they're getting hit with threats against power outages, potentially power safety public shutdowns. So there's a lot of things that we don't want to undermine the need for resiliency and business continuity. And then lastly, what we're seeing is, because of that onset from the state that's transpired to the local authorities having jurisdiction, we've started to see a lot more opportunities for direct access or clean community choice aggregates, community choice energy, so CCAs or CCEs. And here in San Diego, I think Solana Beach has theirs. I think City of San Diego's is about to get theirs. City of Oceanside is their talks stalled with the current time. So you're starting to see a lot of these CCAs pop up, but basically what they allow you to do is consume 100% clean electricity today, in present day. So the thought is, if you fully electrify your facility and you consume 100% renewable electricity, you are zero carbon, or and so that's the idea for those clients that are looking for that outlook. So I guess I'll stop there and just open it up and see if there's any questions from the group. Give a little bit of space and some breathing room. All right. Well, and feel free to use the chat window as well. I'm still kind of learning how to actually even access it. So if I do overlook a chat, Denise, if you want to let me know that that one came in, you can certainly bring that to my attention.
Sure.
So how do we do this? So it's like, that sounds great, Jeff. I get it. We're fully electrified, but we have boilers, we have natural gas that's on site. So so again, I'll go through kind of maybe in that same kind of spirit of that 4-step process. well, step one, just applying the best practices and reduce those heating needs. So again, being in the life science industry, and we have a lot of water for injection systems that's traditionally done through distillation. Doing that through membrane technology with ozone sanitization has a huge impact and a huge ripple effect. And I'm not going to go through necessarily, all these on the screen, but really there's a lot of things that you can do to reduce before you produce is kind of the mantra here. So certainly turn down the dial, lower heating values. I can't tell you how many times I've seen 180 degree leaving water temperatures in San Diego, where we have a low of 40 degrees. That 180 degrees that came from ARI, which was really a standard that covers all 50 states, or at least the 49 states. And so to apply that same temperatures to a temperate climate like San Diego is just it's quite honestly it's overkill. So reducing those hot water temperatures can again have a ripple effect as far as reducing the need for natural gas and steam and otherwise. So number two was removing those fossil fuels. So again, it's like, well, hey, hold on, I got this boiler system. What am I doing instead of a boiler? Well, these are some of the different electrical strategies for heating. So heat pump central plant, VRF, and then heat recovery chiller. You can see that I've graded out a lot of these because some of them are, again, I took this from more of a life science advanced technology, kind of more campus perspective. But certainly if you have a smaller facility, that rooftop heat pumps might work just great, or water source heat pumps that could work very well for a smaller facility. So these are different strategies, and I am part of a green building network, and we've issued a technical request to different manufacturers that may or may not be on the phone, asking for, we need more of this available to us as specifying engineers. We are heading in this direction on behalf of client requests and as well as industry trends that are kind of putting us there. And so the industry's catching up, but they need that impact. So certainly I'm providing that input, and if there's clients on the phone, if they want to provide that input to myself, and I can convey the message, or directly to your manufacturer of choice, the more requests, the more likely it is to happen. That third bucket was that, that resiliency standpoint, so that on-site renewable energy storage. And so again, these are some different strategies, and I've kind of graded back some ones that are probably maybe a little less, maybe they're not mainstream, or maybe they're cost prohibitive, and then darken some of the ones that are more apparent. One of the simple ones that I really like is even number 11 on this list, 10 and 11. So we're getting hit with these 4 to 9 p.m. Time of use peak pricing from SDG&E. Well, why not turn down the temperature of the building, across the board a degree or two, starting at 3 o'clock? And what about, instead of running your chilled water plant at 42, 44 degrees, why not subcool it? Drive it down to 38 degrees. It's interesting that when I got into the industry, we were always talking about running our chillers at night when it was most efficient. But now we're talking about run them during the day, because that's when we have this influx of photovoltaics on the grid. We actually want to run more power during the middle of the day. Our minimum pricing is during that 10 to 2 o'clock. So that's when we're going to have the most favorable rate. So if we can run our equipment from 10 to 2 and transfer the energy away from that 4 to 9, there can be some significant cost savings associated with that, both demand charge as well as the commodity. So this is, I was going to take you through a couple UCSD examples, because I do feel this is their tagline, the world's largest, most diversified portfolio of thermal electric storage systems. And I will try to run through this pretty quick, because I know we have an hour all together and we're 25 minutes past, but I want to allow some room for Q&A. But before I dive into UCSD, again, I'll take a pause and just see if there's any questions from the audience. Denise, I still got everybody? Still got you online?
Still got me. Still got everybody.
All right.
Yep.
All right. Sounds great. Well, so UCSD Example. So they really are pioneers when it comes to a lot of this implementation. So this is nothing new to them. They've got a 42 megawatt microgrid. Today, that's actually, I think it's exceeding 50 megawatts. So it's a pretty good size. I was fortunate to be involved in their East Campus Central Utility. So they have two central plants on the west side of the 5 freeway and on the east side. What you're seeing here is they've since gone away from this. This is a single axis photovoltaic. If everyone's seen my mouse on the screen on the left-hand side. And then down here, this is a 2 axis. So it's following the sun in both, the east-west as well as the north-south direction. And then they've got some static solar photovoltaic. And then this is a 2.8 megawatt fuel cell, which that's the project that I was involved in. And over here, they have a renewable natural gas fuel station for their natural gas fleet vehicles. And in this foliage, they now have some battery energy storage. And out here in the parking lot, they've got some electric vehicle infrastructure. So pretty amazing. And I'll take a quick dive into those different components. So what you're seeing here up on the screen is the 2.8 megawatt fuel cell, and that's providing roughly 8% of the campus's base load. That is run off of renewable directed biogas. So this is 2.8 megawatts of carbon-free emissions. And so your question is, well, where is this renewable directed biogas coming from? Well, that's coming down from Point Loma wastewater treatment plant. So UCSD has an agreement with the power plant, and those renewable molecules that are being injected in the pipeline, they are paying for that, and then they are consuming it on the natural gas grid system. So it's not necessarily considered an offset by the rules, but it is kind of a little bit, you are injecting it here and consuming it elsewhere. So it's just aware. So one big thing about the fuel cells are great that they consume hydrogen and oxygen, and the byproduct is power, obviously, as well as heat and water. So with heat, that's a lot of heat that's coming off the stack. And so what do you want to do to capture some of that heat? So this was where my project came into play, and I was able to grab that heat and run a 350 ton absorption chiller, a direct fired, exhaust fired absorption chiller. And this was the world's first. So this was a really exciting project to be part of. And you can see this being rigged into place. And here's the final product, which again, the fuel cell in the middle of the screen, and you can see that exhaust ductwork making its way over to the absorption chiller. You can see the diverter valve up on top, so that when you have to do maintenance on that chiller, you can bypass that exhaust air out the stack. But that exhaust, that's coming out at about a little over north of 700 degrees. So there's a lot of energy that is available to capture. Again, I won't go too far in the details, but really there was a lot of positive feedback. Fuel cells, they're very quiet. They're very they don't have to go through the same AQMD, air quality restrictions that an engine or a turbine might. And because we were using that directed biogas, it met the university's pretty aggressive goal of climate neutrality by 2025. So that's all exciting things. So we talked a little bit earlier about time of use, and so what you're seeing in the background is a thermal energy storage tank starting to be erected. And so this is where I kind of make a fun joke about saying, all the architects on the call might say, "Wow, that's a gorgeous tank," and certainly that is. So this is 1.2 million gallons, and there is space, real estate for 2 of them. So a total of 2.4 million gallons of thermal energy storage. And as an engineer, I look at that and I think it's gorgeous. But the architects, again, I'm making a joke. They came up with this strategy to actually wrap it. And I thought this was quite brilliant. So you have your parking structure with your circular flow going around, and you kind of have that dead space in the middle. Well, what better real estate to, stealth, this 2.4 collective million gallons of thermal energy storage. So that's again, kind of an exciting novel concept. Also talked a little bit earlier about the battery energy storage. So BES, BESS. So this was 5 1 megawatt hour battery energy storage. Batteries have come a long ways. So this was, again, I want to say about 10 years now. And now we've got the Teslas of the world, and you've got the mega packs. I know locally Solar Turbines was getting into the battery business a little bit. I think they may have backed off, but anyways, there's a lot of players. The cost is reduced dramatically, and so this is again exciting area to be able to shift that time of use and kind of play the game with the utility. And the utility, in their defense, isn't necessarily playing the game. It's really it's Econ 101. It's supply and demand. So as the supply drops off, the demand either remains or is even increased from that 4 to 9 p.m. Inevitably, the prices are going to fluctuate accordingly.
We do have a question.
Yeah.
I think Jean wanted to answer this. How is the thermal energy stored, from a few slides ago?
And I can certainly answer that. Jean, are you unmuted or?
Hello, can you hear me?
Yep.
Yeah.
We can hear you.
Yeah, so the question is, and I tried to answer it in a chat box. I answered the other question, but it won't let me answer this one for some reason. So I'm not familiar with this particular energy storage, but primarily energy storage has to do with either storing primarily chilled or hot water or ice. And the idea there is to create the energy during cheaper off-peak periods of time when there's plenty of cheap energy, and then to store it and then discharge it out of the energy storage tank during high peak times. And there's a variety of ways you can take that chilled load, whether to subsidize your HVAC or in other ways. The bottom line is you're storing energy to use it later. Jeff, do you know particulars of this particular system, what they're using it for?
Yeah, and Jean covered it perfectly. So this one was chilled water, but generally the three mediums are either chilled water, ice, or newer technologies called phase change, which is really just a kind of a gelatin type substance that has different freezing properties as compared to ice. So those are generally your three mediums, but this particular one, whenever you see a million gallons or more, it's almost inevitably going to be a hydronic, so chilled water. So yeah, and please, by all means, grab me if there's any, because I'm not able to see the chat window for some reason. I'm sure it's on my end, but so feel free to jump in if I miss somebody else's question. This is one that's pretty exciting. So this is, I think most people are probably familiar with charging an electric vehicle, which is traditional grid to vehicle. What people may not be as familiar with is vehicle to grid, so bidirectional. And people on the phone might be saying, well, hold on, this EV is, this is a small little battery. I mean, we're talking about 1 megawatt hour over here. Well, I mean, the theory is that if you've got a maybe 100 kWh battery, and maybe you have 100 cars, now you got some real energy storage. And then of course the person that's hearing this is saying, well, hold on, I got to get home at the end of the day. But the reality is that most of the EVs that are coming out today, they might have 300-mile range, and your average commuter is doing 30. So 90% of your battery is not being used Monday through Friday for 51 days and weeks a year. And certainly we're in different times for the moment, but even when we get back to normal, the vast majority of time you're not using a vast majority of that battery capability. It's really, we have that battery partially for range anxiety and partially because we have that occasional trip up to LA or Riverside or elsewhere, right? So using that available capacity has a tremendous ability to further play the game with supply and demand as that electrical infrastructure changes in the future. So this is so really this was just a whole recap, you know, of UC San Diego, and you can see on the screen that you know it is quite a diversified portfolio of thermal and electric energy storage. That is a good point. You know, so Jean mentioned earlier about thermal energy storage being, you know, those three mediums, and more generically, when we say energy storage, that's inclusive of electric and thermal. So electric generally being that battery, the thermal being those three mediums, but there's other emerging technologies as well. For instance, maybe hydrogen storage. So maybe you have excess renewable energy and you want to you know, run a fuel cell in reverse, call it electrolyzer, and split those atoms and have hydrogen storage so that you can access that hydrogen at a later date, so or a later time of day. So a lot of things that are on the cutting edge. They already exist in maybe pilot form, but they're not quite mainstream, and so pretty exciting to see what the future holds. This slide really just wraps up the UC San Diego, and it just talks about not everything would have been possible without a lot of incentives that have been provided. So this is a little dated because you can see there, you know, UCSD implemented quite a bit of this a while back, but there's still a lot of incentives today. But probably the biggest one is the ITC, the investment tax credit, and that's a federal program. But there's even some state level programs. So a lot of the ones for solar have already expired, with the exception of the ITC. So anyways, if there are questions regarding incentives, please, you know, reach out and we can dive into more of those details. So with that, we have 20 minutes left. I'm going to run you through a quick example of a building that we designed from scratch. But again, I'll take just a minute pause and see if there's any questions on UCSD or otherwise.
Hi, Jeff. This is Lydia. I chair the membership committee for the chapter. I'm curious to know that first world that I think it's called a heat storage. I'm not sure what it is, but who created that?
The thermal energy storage tank?
Not that one. The one that you deployed.
Oh, the fuel cell.
The fuel cell, right there. Nope.
So,
go back.
So the,
go forward.
This one?
Right there. Yeah.
So the fuel cell was by Fuel Cell Energy, FCE. They're out of Connecticut. And then this chiller that you're seeing on the screen, this was the absorption chiller, and this was by Broad. So this is from China. Okay. You know, I used to work with a gentleman that had quite a bit of experience in the absorption chiller doing cogeneration, and we had looked at quite a few of the different manufacturers, and Broad seemed to be one of the more robust ones that was out there. So not to say that the others weren't, you know, competitive, but yeah, Broad was a pretty well received manufacturer.
Very good, thank you.
Any other questions from the group, or any chat window questions that I might have overlooked? All right, well, we'll jump into this. This is a quick one with 15-20 minutes left. So confidential client, AT&P Manufacturing. So this is an advanced therapy medicinal product. So if for those that maybe might not be in the life science community, that's AKA cell therapy or gene therapy. We're seeing this just being an explosive market for our company, you know, and for the entire biotech industry, but it's really like individualized medicine. So rather than just creating a generic drug and seeing how different people react differently to that drug, we're actually taking cells from an individual and manipulating that cell, putting it back in the individual, and with the idea that we're not just creating therapies, but we're actually creating cures. So that's, you don't use that word cure very often in biotech pharma. So to say that word is pretty exciting. So I guess, you know, really what I wanted to back up and kind of, so why am I even bringing that up is that I feel like in traditional biotech and pharma, both on the quality side and on the facility side, and everybody's kind of like, this is the way that we've been doing it for 20 years. This is the way that it shall be done. And that mentality transpired even to our MEP approaches. And I feel like this ATMP and these cell therapies, and it's a new revolutionary idea, it really started paving the way for different thoughts towards, you know, a facility design and saying, well, hey, hold on. I mean, we don't have to just stop, you know, in the clean room. We can, you know, start thinking about alternatives, you know, outside of the clean room and, you know, in the back of house in the central plant. So I'm going to skip over this because it's really largely similar to what we talked about previously, but this was some of the things that we enacted for this particular client. And really, you know, how did we create this 100% electrified facility, and how did we remove the natural gas? This client was up in the Bay Area. They were not under a current restriction, but we were anticipating that their city was likely going to implement, and granted that they would be, quote, grandfathered in, you know, they also wanted to be leaders and pioneers, and in the words of healthcare, first create no harm. So, you know, not just creating these therapies and these cures, but also doing their part from an emission standpoint. So, you know, we went through like that initial design charrette and charter system, and really started talking about what story do we want to be told. So what you're seeing on the screen is it's a mouthful, but an air-cooled water heat recovery heat pump. And what you're seeing is that it looks like an air-cooled chiller. And it essentially is, when there's no heating, it is. There's 4 pipes on the side. This is chilled water, this is your larger pipes. However, there's another heat exchanger that is allowing that heat to, rather than be rejected to atmosphere, it can be rejected to your condenser barrel and actually create that heating hot water. So the beauty of this is ran in a chiller mode, it's roughly the efficiency of a air-cooled chiller. Ran in a heater mode, it's roughly the same. And ran in a simultaneous, we're actually getting COPs exceeding 8. To put that in perspective, you know, a chiller might be 3, 4, 5. And so to get a COP of 8 is just wonderful. For those that don't talk in COP very often, coefficient of performance, a boiler might be 85, 90% efficient, which is a COP of 0.85 or 0.9. Electric resistant is nominally 100% efficient, so it's a COP of 1. We're not just 3, we're not 4, we're not 5, we're 8. I mean, it's really exciting, and that's why this technology is starting to really prove that it has some future. I'm sure I'm going to get some questions on that, but I'll go through these 4 or 5 slides and then we'll come back to questions. So again, going in that spirit of that kind of 4-step process that we created, you know, step 1, you know, apply the best design and construction practices. Step 2 is remove the fossil fuels. Step 3 is to provide that on-site resiliency. So one of the challenges that we had with this client was that this facility was originally designed as a distribution warehouse. So it was we say it was a greenfield, but it was really, technically it was a TI because there was a different developer that was developing this warehouse distribution, and then we were coming in and making it this biotech facility. Well, not a lot of support on the roof structure to be able to handle all the piping, the ductwork underneath, and plus the solar photovoltaics on top. So that was a huge challenge. So just something that I would collectively say to the group, something to be aware of. There is alternatives, carports, but you know they are going to cost a little bit more, whether that's a direct cost or you know, through like a power purchase agreement. The other things to note is just be aware of some of these like state fire marshal codes. So you can see the runways to allow the firefighters to make their way to get to the center of the building. So little kind of nuances, you know, whoever's doing your PV design certainly should be aware of those, but just you know, things to kind of keep in mind. And then again, so we've created all this, and I didn't mention, but that was upwards of 1 megawatt. So this was, I think we were pushing about 940, 980. I forget exactly where we landed, but it was just shy of a meg, and so you know, good size solar photovoltaic. But because the sun's not always shining, how do we transfer that to when we want to, you know, discharge it, you know, especially during that 4 to 9 p.m. time frame. So this is a Tesla Megapack. It's pretty exciting. I got a picture 2 weeks ago showing the slab was poured. So both those water heat pumps, as well as this battery energy storage, is actually supposed to be set into place in the weeks ahead. So really looking forward. I was hoping that it was already done. It was supposed to be done back in June to July, and of course things got delayed, but I was hoping that this I had some real picture to share with the group, but for now we'll just have to use the imagination. And this is the cataloged picture out from Tesla. So this is a 1 megawatt hour doing, I can't remember if this is 250 or 500 kW discharge, but always keep in mind whenever you're talking about battery, there's the kW and kWh that is associated with that battery. How much storage does it have, and how fast can it discharge?
It's definitely a pretty system. I'm getting a ton of info on tours for when we open up as a society and can go out and about again. We have a lot of locations that would be really great tours for IFMA.
Absolutely, absolutely. So then this brought us to that fourth bullet point of consuming that 100% renewable electricity or carbon-free. And so what we're finding is a lot of these CCAs, these community choice aggregates, have a similar 3-tier program. Tier 1 is, believe it or not, a cost savings compared to your local utility. Sounds a little bit kind of like, oh, hold on, this is too good to be true, but the reality is that most states, and I would say, when I say most states, literally, about 50% have what's referred to as a renewable portfolio standard, an RPS, and so ours in the state of California, our RPS, our renewable portfolio standard, is to go 100% by 2045. But we also have some milestones along the way, and I want to say it's like 50% by 2030. So what that does is it creates a requirement to the local utility to say, hey, your traditional natural gas fired plant, or your nuclear power plant, or whatever that is, you need to now have this renewable offset. So rather than them create all these wind farms and these hydro and these solar photovoltaic farms, they actually just procure it through private industry, and that allows them to not have to run their natural gas peaker plant. And so that's really where this whole kind of why it starts to make sense. Going back to the tier system, so again, tier 1 is that small savings. Tier 2 is usually like a cost equal, only you getting a higher percentage of renewables. And in this case, it's for this particular jurisdiction, it was 100% carbon. And then for those that want to go fully renewable, there's a 1 cent premium as compared to the local. Again, this was PG&E up in the Bay Area. And again, the difference between carbon and renewable is just hydro. So hydro does not fall into the 100% renewable, while it does fall into the carbon-free bucket. And so with that, this was, again, another world's first. So, I talked earlier about that world's first combined heat and power fuel cell absorption chiller for UC San Diego. And this is the world's first zero carbon emission ATMP facility. So pretty proud of that. One thing, I'm not going to read the bullet points here, but one thing I will point out is that down the list is that 12 million gallons of annual water reduction. So for those on the call that are responsible for, their energy, maybe the carbon, but also the water, and you got to think about, also the maintenance associated with that water equipment. When we deal with these air source water heat pumps, there is no cooling tower. So that's a huge amount of savings. And in 2 or 3 different analyses that we've done, the cost between doing this heat pump design and doing a traditional water cooled central plant has actually been within a couple $100,000 of each other on a $2 million effort. So in this one, it was actually like $100,000 or $200,000 savings, capital savings. But the other part of it is, yeah, there's significant water reduction and the associated chemical treatment and the associated maintenance with operating a cooling tower. So so that's something to keep in mind. The other one that I'll maybe touch on is that last bullet point, which just talks about $0. So how are you getting $4.5 million worth of photovoltaic and battery at no charge? Well, it's become so lucrative that different financiers are saying, we'll pay for the capital and we'll sell you that power for less than what the utility will charge you. So the utility is going to charge you maybe 20 cents. We'll charge you 12 or 14 or whatever that power purchase agreement, depending on the terms. Usually they want longer the better, but minimum of 10, ideally 15, really ideally maybe even 20. But So that's a very attractive thing from a financing option. So $4.5 million worth of photovoltaic and battery at no charge to this client. And I think really, I think my last one here was really just, you know, we, CRB ourselves, we're walking the walk as well. So our facility is 100% electrified. We put in a water-cooled VRF system. So we converted our, what was previously a water source heat pump, but we wanted to blow out the ceilings, but we didn't want those compressors, you know, shaking above our head. And so we went ahead and ripped out the water source heat pumps, put in a VRF. It's nice and quiet. We're still getting the advantages of the water rejection. We submitted our Energy Star score, and then in 2018, you can see that we did win the EPA Charter Tenant Award win. We were one of 18 offices to win that award. So pretty proud of that. And so, yeah, I mean, what we can do for our clients, what we can do for the, you know, ourselves, and it's been great.
I have a question about the financing on the last slide that you just had. What, I mean, it sounds so crazy amazing. What are companies saying as obstacles to that? You know, why isn't everybody jumping on that? What are the challenges?
The biggest challenge is probably terms. So even in this example, this was a tenant that had a 15-year lease. So that they had that going for them. They were investing a lot of money. I want to say this was on the magnitude of an $80 million job. They were investing a lot of money, so they wanted that 15-year lease. The irony was that they started their lease before the building was built, and so their power purchase agreement was offset by about 9 months. And that might not sound like much when you're talking, you know, 9 months over 15 years, but just that simple fact that, hold on, our lease expires in this building, you know, in January, but our lease on the equipment doesn't expire until, you know, November or October of that year. That was a struggle. I'm dealing with a client right now, and we're talking similar conversations, and theirs is maybe on more of the 15-20 million side, and they only have a 5-year lease with plans to extend. So anyways, those leasing terms, especially when you have a broker, you know, somebody else that owns the building, and then you have the tenant, that's probably the biggest thing where I see the challenges.
Gene, there's also the question of credit worthiness, and also the other very attractive thing about these new energy services like power purchase agreements is these are off balance sheet terms, and so a lot of times, depending on how accountants look at the finances for the company, there might be a lot of attractiveness of keeping these types of investments off your balance sheet. And of course, with that, you have to sign a multi-year contract, but there's also a way there to hedge the electricity costs of natural gas and electricity. So there's multitude of benefits to these types of products. And basically, like Jeff was saying, the bottom line is these technologies have become so competitive that they can be often much cheaper than what the utility is able to provide, and that's where basically it's kind of like a shared savings kind of arrangement where someone else is taking on all the risk, and they even provide guarantees on electricity and heating and cooling that they're basically selling back to the owner, and that's where there's a huge component with resiliency, and that's really hot right now, as of course we're experiencing a higher and higher number of utility grid outages. So multitude of benefits on that side, and it is very attractive right now. So if you have any questions about that, feel free to reach out to Jeff and me to provide you more information on it.
And really, that did conclude our presentation. So, you know, I wanted to leave 5-10 minutes, and so that's kind of perfect timing. So, anybody else that wants to maybe take themselves off of mute or use the chat window, we can certainly go back, review any slides, or if there's any additional questions.
I'm curious of what your thoughts are of proceeding with these kinds of building operations within the time of COVID, or even, you know, when everything goes back to normal, is this something that you see kind of being put on the back burner or actually on the forefront?
With regard to COVID, I mean, specifically?
Yeah, with regard to COVID and, you know, regaining the economy and everybody going back to work and.
You know, I don't know that I've seen too much direct connection. The irony is a lot of the things associated with COVID or even as we start to enter this kind of, you know, restricted environment is going in the opposite direction from an energy consumption. You know, a lot of suggestions coming out with using more economizer, using more ventilation, putting in additional filtration. All those things are driving energy in the other direction. But largely, you know, I think the sentiment is that, you know, COVID is we hope, you know, is you know, maybe a 12-month, maybe it's an 18, hopefully it's no more than 2 years, but we don't know. But really, you know, we're talking about a much longer commitment. Those clients that I had mentioned earlier in the presentation, you know, a lot of those are 2050. Some of the more aggressive ones are 2040. We're seeing 2030. And then in the case of like UC San Diego, they're even 2020 or 2020 or 2025, depending on what metric we're referring to. So I haven't seen anybody say that they have changed their long-term planning with regard to COVID.
Interesting, thank you. I don't see any questions in the chat box. Does anybody have anything? Well, thank you for that topic. I personally think it was extremely interesting. I love the case studies. I think it was helpful to know where we should go on our tours when, you know, everything opens back up. Again, thank you so much for your time today. I hope everybody's walking away with a little more information on this topic than they had before. Glenda, are you there?
Yeah, I'm still here.
You want to say anything?
I just wanted to, again, thank everyone for coming or attending this little presentation. And we're hoping to have another really great one for next month. Karen, do you have that information?
Next month is Jessica Cooper with the Well Building Standard. She's going to talk about the brand new health and safety concept that is very relevant right now.
We're still talking about holding some in-person events. I know there are still concerns about that, and we're following all the guidelines from the city, this county, and state. But if anyone does have any questions or you know, thoughts about that, please go ahead and just email us as well. And we'll see what we can do to address those questions and concerns that you might have.
Jeff, we do have one more question from Kelly, and she asks, do you have any recommendations for shorter term leases?
Ooh, that's a tough one. Shorter term leases. I mean, there is a favorable payback, which is why some of the financiers are even interested in putting their capital out there. So, I mean, it might sound obvious, but one suggestion is actually to, you know, pay for the capital yourself and reap 100% of the benefit rather than just a shared savings. So that might sound obvious, but that's certainly an option. For most of us, we're not in the solar business, so people want to kind of keep their money in the science or whatever it is that they are doing. You know, whether that's you know, aerospace or biotech. So I guess with that being said, I don't have a good answer for financing for short-term leases.